So, you shared some of the topics with me, and I decided to start from the very basic, which is Pythagoras theorem. And Pythagoras theorem is basically it forms basis for trigonometry as well. Okay, so I'm gonna start our first lecture with Pythagoras theorem, and we will move forward towards the trigonometry then. Okay, I'm gonna share my screen with you. Let me know once you're able to see it. Yes. Is it visible to you now? Okay, perfect. Right. So, our today's topic is Pythagoras theorem. So, do you know something about Pythagoras theorem? Anything? Yeah, perfect. And what are these A, B, and C's? Yeah. So, I should write it as C square equals to A square plus B square. Okay, perfect. Okay, let me tell you something that why we gonna use these theorems and from where this theorem comes. This is basically Pythagoras theorem is basically for the triangles. Okay, and we have four different types of triangles overall. We have equilateral triangles, we have isosceles triangles, we have scalene triangles, and we have right angled triangles. Okay, and this Pythagoras theorem is specifically for right angled triangles. Is it good? So, what are right angled triangles? Do you have any idea? Yeah, great. Right triangles are the triangles having 90-degree angles. Let's say I'm gonna draw a triangle here and these. So these two lines are perpendicular to each other. These both are straight lines and they are making 90 degrees with each other. So we can say these two lines are perpendicular to each other. So if I connect these 2 points and form a closed shape, so now it is a triangle. A triangle is a shape having 3 angles. So I can name it as A, as B, or you can name it as B and as C here. Okay. Now, so can you please tell me which side is hypotenuse in this triangle? Opposite the right angle, this side. Perfect. This is the hypotenuse, so we can write it as HYP. And now rest of these two sides are base, or you can say adjacent, and perpendicular, or you can say opposite. Okay, so this side, if it depends upon the angle. Okay, now if this angle is of 90 degrees, right, and still we have these two angles. Let's say if I say this angle as x, and if this angle is y degrees, right? So now it depends upon the angle, and depending upon that angle we can decide which of the side is opposite and which one of the side is adjacent. So let's say if I target y, and I'm trying, if I want to find these two sides, if I want to find about opposite and adjacent. So according to y, so let me write here, according to y, according to angle y degrees. Okay, hypotenuse is fixed. We cannot change hypotenuse. It is always the side opposite to 90 degrees. It is fixed. It's in the slope form. But the opposite and the adjacent may change. As here we are talking about this angle, and the angle is here. This is the angle. I am coloring it with the red sign. Okay. So now, which side will be the opposite? AC or CB? Perfect. The opposite will be CB, and obviously we are left with only adjacent, which is AC. And yeah, yes, please. Yes. So on the same side, if I talk about the angle Y, according to angle X. So on this same here, according to this angle X degrees, CB will be the adjacent and AC will the opposite. Is it fine? Yeah. So these are some basics. Like from these, we can understand that hypotenuse is always the side which is opposite to the 90 degrees, and base and opposite will can change. So this is the whole concept of Pythagoras theorem, and this is only valid for the right triangles. So now in Pythagoras theorem, we can have two types of questions. Okay, I'm gonna discuss these types, and then we will solve some of the questions related to this by taking some examples and practice questions. And first I will solve some questions, then I will ask from you to guide me to solve these questions so that you can practice these as well, and I will share worksheets with you. Okay, moving to the next slide. Now I'm gonna talk about the questions. In Pythagoras theorem, we can have two types of questions. We can have two types of questions. Like it means in, you can say it, exam style questions. Exam style questions. So type 1 is, you are directly you will be given with a triangle, and you will be given with a triangle given with a triangle and find any side. Like as in Pythagoras theorem, we have three sides, and from these three you will be given with any two. Sometimes you will be given with C and A, you need to find B. Sometimes you will be given with A, B, you need to find C, and so on. Type 2. And when you are asked about this to find any side, you will be given that the triangle is a right triangle. So as a resource, you will be given with this point. Okay. Type 2. In type 2, you will be given with all sides. In this type, you will be given with all sides. you will be given with, sorry, with all sides, and what you need to do is to prove, or you can say to verify, whether the triangle, this is a triangle sign, is right or not. Perfect? You getting my point? Okay. So in your exam, they cannot change any questions other than these two types. So type 1, you will be given with the triangle that this is a right triangle, and prove, find any of the side, any of the missing side. And type 2, you will be given, these two types are basically converse of each other. Okay. So now let me solve an example so that you can clearly understand these types. Let's say I'm taking a random example. I'm worked example here. Okay, let's say we have a triangle, mm, this in this direction. This is okay. Gonna join these 2 points. Let's say I'm assuming this side is P, this side is Q, this side A, this point is R, this vertex is R. So at Q we have a 90 degrees. So it is clearly a right triangle. So can you suggest me the length of these sides? What will be the length of PQ? Any? 15 centimeters, right? And for PR, sorry, 17. 17 centimeters, and QR is to be found. Okay, QR is missing. Okay, one more thing. I missed to tell you that whenever you are solving any question related to Pythagoras theorem, keep this thing in your mind that the hypotenuse side is the longest side of right triangle. Okay, yeah, it is always there. The hypotenuse is the highest side, largest side. The length of hypotenuse is greater than the other two sides. It is always. So it is 15, it is 17. So it is difficult to decide whether PQ is adjacent or opposite. So when you are finding a side QR, it doesn't matter by the way, but if so, you can use this angle which is at R as our reference angle. So now, according to this angle, PQ is opposite or adjacent? Yeah, it's opposite. So instead of writing the Pythagoras theorem as c square equals to a square plus b square, I think I should write it as hypotenuse square equals to opposite square plus adjacent. This would be more suitable. So here hypotenuse is PR. According to our figure, hypotenuse is PR. I can write it PR square. Opposite is PQ, so I can write PQ square, and QR is adjacent. QR whole square. So this is the Pythagoras theorem according to our triangle. So now put these values. PR. PR is 17 centimeters. So we can add the unit at the end. So PQ is 15. So I can write it as 15 square plus QR whole square. So do you know what is 17 square? Okay, if you have a calculator, you can use it. Yeah, yeah, it's 289. Okay, if let's say sometimes if you're not allowed to use your calculator, or if you forgot to bring your calculator in school or in the test, it's simple. You can do it manually. 17 square is basically 17 times 17, right? You can, yeah, you can simply multiply it. 7 times is 49. Yeah, then 4, 7, 1 times 7 plus 4, it's 119. Then it's 1, 7, it's 9, it's 8, it's 2. So keep those both in your mind. So 17 square is 289. Similarly, what is 15 square? Yeah, it's 225. QR is to be found. We cannot write any value for it. QR square. So what will be our next step? Changing the sides. It means we can shift this on the left side, or we can subtract 225 on the both sides. So what you suggest? Should I yeah, should I shift this 225 on the left side? Yeah, yeah. So it's 64 equals to QR square. Do we need to find QR or QR square? Yeah, we need to find QR, the length of the adjacent. So what we need to do here, how we can remove this square? Yeah, by taking square root on both sides. So what is the square root of 64? Yeah, perfect. That is correct. QR is 8 centimeters and you are done. So how is it? Is it easy now? Yeah, it is easy. So this was a very basic question, and now I'm gonna solve a question in which we got composite figures, like more than one triangles are combined in a same triangle, right? So let me take another example. I will share these slides with you at the end of the lecture in the WhatsApp group, or you say, if you say, I can email you as well. Okay, moving to the next question. Let me take another example. For example, we have a triangle here. Worked example 2. Worked example 2. So again, I'm taking a random example from a. Okay, this is this is the other side. Okay, and by joining these two, this is a right triangle now. And next is we have another triangle which is adjacent to this. If I write here and joining this, now we have two triangles and both triangles are right. You can see here, this is a triangle having 90 degrees here, and this is another right triangle having 90 degrees here. So this is a composite figure, right? So we can label it as P, Q, R, and S. Now the lengths of these triangles are, this is 45 centimeters, this length is 53 centimeters and this length is 30 centimeters. So this is the all information we have. Now look at the requirement, the demand of the question. What question says? The question is find QS and SR. Find QS and SR. So first of all, we need to figure out that the side QS is hypotenuse or opposite or adjacent, and QS QS is the side of which triangle? This is triangle number 1, this is triangle 2. So this this QS is a side of triangle 1 or 2. So this is common in both, right? So to find QS, can we use both triangles here? Can I use two? Yeah, perfect. So to find QS, we cannot use QSR, triangle QSR, because in this triangle, we know only one value, which is 30 centimeters, which is the hypotenuse of QSR. So to find any side, we should know about two sides. Yes, but by looking at this triangle PQS, we are given with two sides, we can easily find the third one. So now 53 is the hypotenuse. You can consider 45 as opposite and QS as base adjacent, or you can consider QS as opposite or 45 as adjacent. It doesn't matter now, right? You got my point? Okay, perfect. So can you please guide me how to apply Pythagoras theorem on this triangle? Yeah, yeah, perfect. It's 53 square. Yeah, it doesn't matter. One of the sides is 45, so you can write 45 square plus QS square. Can you write this? Yeah, we can write. So we're not bound to specify the sides here, like that which QS is opposite or adjacent. We are not bound. Okay, so we can use it directly. So what is the square root of 53? Sorry, what is the square of 53? 2809, right? And it will be, I think, 4000 something, 45 square. Sorry, 2000. 2025 plus QS square, and you can simplify it. It will be 2 minus 225 and QS square. Sorry, it is equal sign here. 700. It's 784. So now just take the square root of both sides and it will be 28 centimeters. So now we have this length which is 28 centimeters. Now the second part is, in this part we need to find SR. As we have these two lengths, now I think we can easily find SR. Yeah, yeah, perfect. That's great. Excellent. Yeah, excellent. SR square. Excellent. Okay, the 30 square is 900 and 28 square is, we know, 784 plus SR square. So 900,784 equals to SR. What is it? 900 minus 784? 116. It will be 10 point something, I think. 10.7 centimeters. So this is the method by which we can easily use Pythagoras theorem on the composite example. So this was again a very basic example. You can say it as up to the intermediate level. So let me do an example from the advanced level. Uh, so if you have any questions till now, you have any confusions or questions, you can ask, please. Yeah. So you did that. Uh, you're done with that homework. Okay. That was, I think, about quadratic equations. So just tell me that quadratic equation. So can, what was that, please? Okay. X square plus 8x minus 5 equals to 0. Okay. You saw how you solved it? Okay. Perfect. You used quadratic formula. Okay. Okay, that is perfect. We will do we will do it thoroughly. Like as you mentioned that you you struggle in quadratic equations. So this is very it is a basic, but it is a very vast field, vast topic. We can discuss how to simplify these quadratic equations, how to convert the word problems into quadratic equations. So in your papers, when you're gonna appear, when you're gonna attempt the final papers, you will see some of the questions in which the equations are not directly quadratic equations. So in those situations, we need to convert those fractions. Sometimes you will be given with fractions, and you need to simplify those fractions, and you will get the quadratic equation. And then you have to solve that equation using any method. You can simplify by uh, if it is possible to solve it using middle term break method factorization, you can use that, or you can use completing square, or you can use quadratic formula. uh, I remember we did last time we did factorization and quadratic formula. We missed completing square method, right? Yeah, it is fine. Basically, the topics you shared with me. So I looked at those topics, and I decided to start from the scratch, which is very basic, which is Pythagoras theorem. And I will finish this topic in today's class. And after doing two or three more questions, this topic is done. This topics will almost be done. Okay, we will do another example related to this, and then I will do some questions related to converse of Pythagoras theorem, like in which you will be given with the sides, and the demand of the question will be to prove that whether these sides are sides of a right triangle or not. So this is almost a last question related to find any side using Pythagoras theorem. Then we will do some questions related to the converse. Okay. This is worked example 3. Worked example number 3. Okay. In this, again, we have a triangle, for example, here. Let's say this is a triangle here. Yes. Sorry, this is in the tilted form. We need a straight line. Okay, that's perfect. And this, and I join this with this point. So this is a triangle, which is clearly a right triangle. Then we have an other triangle, which is composite to it. Let's say here is a point. I can change the color for this second triangle. I should change it as, yes. Okay, we have this line, and here is a 90-degree angle by joining this line with this, and this is again not a straight line. Let me try to draw a straight line. Yes, perfect. And we have a line here which is dividing this. So let's say this is here. So perfect. We have these two lines. I can label this length is of 27 centimeters. This length is of 36 centimeters. This length is okay. So now from this point to this point, this length is 2a centimeters, and this length is a. And this is b centimeters. Let me redraw this line, please. Yes. Okay. So this this side is 2 centimeters, and this is only a. This side is b centimeters. So this is the total information related to this. So this is 90 degrees, and here the angle is 90 degrees. I'm labeling it these angles, coloring these angles with blue so that we can clearly differentiate. Okay, here we have two right triangles. Perfect. Which one of this is with blue and the other one is this red. But in this red triangle, we have this line which divides this. So what we need to do in this triangle, we have two unknowns here, a and b, as these all sides are given now. So this is 36, this is 27, this is 60 centimeters. So we have two unknown variables from the figure. Find a and b. Yes. So to find a, we need to, okay, this is figure 1, and this whole figure is figure 2 currently. Like, this is figure 2, this is figure 3. Okay, to find a, firstly, I'm gonna find a. So to find a, which triangle should I use? 1, 2, or 3? 1. Why 1? Yeah, it has the values of two sides, which which have 27 and which are 27 and 36, right? Okay, so sorry, so this side is hypotenuse or opposite? Yeah, perfect. So by using Pythagoras theorem, like I can write here using Pythagoras theorem, so that to avoid any type of confusion, I'm writing this Pythagoras theorem on figure 1. So this side is hypotenuse. So what is the length of hypotenuse here? 3a. Perfect. That is great. 3a square. It will be then 27 square plus 36 square. Can you put the whole value in the calculator and find the answer, please? 27 square plus 36 square. 729. Okay, sorry, 1296. 2025, and if you remember in previous question we got 2025 by taking square of 45, I think so. So now as we are trying to find a, so it means we need to remove this square, and we can only remove it by taking square root. So by taking square root, this is square root of 2025 is, I think so, 45. Yeah, perfect. We need a. So divide both by 3 by this, we can write is 15. So this length, the length from point, this 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 length is now 30 centimeters, and this length is now 15, right? Yeah. So this total length will be 45. So we are done with A. Now we need to find B. So which triangle we should use here? Triangle 2 or 3? Both. We should use both. How we can use two triangles like in a single theorem? Sorry. Yeah, I'm just wanna ask that to find this length B, I should use triangle 2 or 3? 3. Yes, perfect. Because we have, if I decide to use triangle 2, I cannot apply even Pythagoras theorem here. Why not? Because I am given with this side 30, I am given with this side B, but I am not given with this side. So this is the one thing. And the second thing, or you can say the second reason why we should not use this triangle 2, because this second triangle is, we are not sure about it, even it is a right triangle or not, as we are not given here that any angle is of 90 degrees. You got my point? Yeah. So we should use triangle 3 here, and this is your homework, that you need to find, you are like required to find this length. You are given with 15, the second side is 60. You need to apply the Pythagoras theorem and find it. Can you find it now? You can tell me, I can write here. Okay, leave the pen and paper. Just tell me, I will write here for you. Ah, 60 is the hypotenuse. Yeah, yeah, just focus on the triangle, please. Yeah. Which side is hypotenuse? B. Perfect. So it is B square, then 60 square, 15 square. 3600 is 225. By adding these, it's 3825, I think so. Okay, perfect. We need B. We don't need B square. So to eliminate, remove B, oh sorry, to remove square, but yeah, 61.87, or you can write 87, or you can round it off to the three significant figures. So you can write 61.9 centimeters. So this is all about the Pythagoras theorem. We did, I think we did many questions related to it. I will give you some practice questions as well, so that you can check yourself that where you stand and how you're able to solve these questions. So now, if you have any questions related to any composite figure or this concept, let me know. If not, then I will move to the converse of Pythagoras theorem. Okay, perfect. So now we're gonna solve some of the questions related to the converse of Pythagoras theorem. So what is it? Converse of Pythagoras theorem. So this converse is basically previously we were doing that we are given that triangle is right, and we are asked to find any missing side. Missing side. But now in this converse, the given will be sides will be given, and find, or you can say verify, the triangle is right. So you got my point. What is the difference between the statement of the theorem and the statement of its converse? Okay, perfect. Let me solve an example. Can you, firstly, we can solve any random example. You can suggest any three sides. Yeah, you can suggest any three lengths. Uh, and I should use the coordinates ABC or PQR. What? Yeah, okay. Triangle is ABC. So firstly, length AB, 10 centimeters. then AC, okay, 23 centimeters, and BC, 6 centimeters. So now verify that the given lengths are of a right triangle or not. So this is the requirement of this question, and this is the information we have. So the only thing we need to focus here is to figure out which one, like this is Pythagoras theorem, hypotenuse square, opposite square plus adjacent square. So how we can uh, figure out that which of the side is hypotenuse? Exactly. The largest side is 23 here. So this is hypotenuse, and you can consider 10 adjacent or 6 adjacent and 10 as opposite. You can say 10 is adjacent and 6 is opposite. So it doesn't matter. So it is 23 square, then 10 square plus 6 square. What is 23 square? 529. 10 square is 100 and 6 square is 36. So 529 is 1. So is it true that 529 is equal to 136? It is not. So 529 is not equals to 136. It means these lengths does not satisfy Pythagoras theorem. If these lengths are not satisfying Pythagoras theorem, it means these are not lengths of a right triangle. If if whenever the sides the length are of a right triangle, those sides will definitely satisfy Pythagoras theorem. This is the only, you can say, this is the only way you can verify that these lengths are of right triangle or not. So this is the basically converse. So I think it was easy. Yeah. Okay. Let me solve some some other examples. Some more examples related to converse. And let me mention here that we are doing converse of Pythagoras theorem. Example. Okay. We can solve some of the like word problems as well here. Okay. Uh, After this question, I will solve a word problem. Okay. In triangle, we have a triangle MNO. In triangle MNO, the sides are MN is 5 upon 13 and the side NO is 3 upon 13 and the side MO is 4 upon 13. It is 4 upon 13. Right. The unit used used here is centimeters. So now we need to verify whether these sides are of a right triangle or not. So, so here we have to deal with fractions. So can you please tell me which of the side is hypotenuse here? MN. How did you know? Yeah, 5 over 13 is the biggest side. As when we are dealing with fractions, when we have the maximum numerator, as denominator is same for all values, 13, 13 and 13, and from all these three values the biggest numerator is in mn, so it will be the biggest value, so it will be the, definitely it is hypotenuse, and no and mo will be the opposite and adjacent. So can you apply this? So it will, how I can write it, 5 upon 13 square, then 3 over 13 square. I'm gonna solve it directly for you to save our time so that I can solve a word problem here, right? So we are short of time now. It is fine. So what is the 5 square? 25? Yeah, it's 13. It's 169. Then 3 square is 9. It's 169. And 4 square is 16. And it's 169. As we are dealing with the fractions, and we can simplify fractions using least common multiple method, right? Using LCM, and they both have the same base, so the LCM will be 169. Yeah, it's 9 plus 16, it is 25 upon 169. So here we have same sides. This is left hand side, this is right hand side, and clearly it, these both sides are equal. So it means that as left and right side, it means that these sides are of right triangle. So this is a right. Perfect. Okay. So I think so. We are almost done with different types of questions with both types, like with the Pythagoras theorem and the converse of Pythagoras theorem. Now let me solve a word problem. Word problems are so easy related to the Pythagoras. They are very easy. You will be given with some, like you will be given that a height of a pole is for example 20 centimeters, or the height of a wall is 20 centimeters. A ladder is, let's say, if this is, let consider it as this is, for example, this is a wall, okay, and they say you that there is a ladder of length, you can say it of 15 centimeters, or you can say 25 centimeters, and that ladder is placed against the wall. So definitely we cannot place a ladder against a wall like this. We need to place it in the tilted form, right? Okay, so they say that this is the height, this is the, then this is in the form of slope, so this will be the hypotenuse. Okay, and they will ask you that find the distance from the foot of the ladder and the base of the wall. So this will be the, so this will be the base. You can say this will be the adjacent. So like this, I'm gonna solve a question. I'm gonna write a statement here. Just give me a minute to move towards. Okay, I hope so. You're not getting bored in my class. Yeah, perfect. Okay, I'm gonna solve some, like we have a square field of 50 meters long. Okay, this is a word problem. Okay, we have a square field. A square field of length 50 centimeters. Okay, as this is a square field, I think all lengths will be same. Yeah, and a barricade is to be placed along the diagonal of the field. A barricade placed along. Do you know what is diagonal of a square? Sorry. Yeah. Yes. Let's say this is a. Let's say we have a. This is a square, for example, and this. Let's say this is a square, and if this length is of 50 centimeters, all length will be of 50 centimeters. So by joining two opposite corners, this is called diagonal. You can join these two as well. So it's up to you. It's your own choice. So basically, in this question, we need to find the length of this diagonal. Okay, this one. So the property of square is all all the angles are of 90 degrees. As all lines are straight, and if all lines are straight, so all the angles are of 90 degrees. So this angle is of 90 degree. This angle is, all these angles are, this is 90, this is 90. So this 1 and 2, these both figures are, these both triangles are right triangles. So if this length is 50 centimeters, this length will also be of 50 centimeters. So the diagonal lengths will be the hypotenuse. Yeah, it would be, let's say this length is L, so L square will be 50 square plus 50 square, and 50 square is, I think so, 2500. Please verify it. It's 2500 plus 2500, so it is 5000 L square. What is square root of 5000? 70.7 centimeters. So this will be the length of that diagonal. So this is how we can solve word problems here. This was very simple. Like you will be given with, sometimes you will be given with a rectangle. For example, if you are given with a rectangle, you know, in rectangle opposite sides are same. In that rectangle, you will be given with two sides, and you need to find. So there is nothing other than these concepts in the Pythagoras theorem. If they ask you to apply it directly, then you will be given with two sides. You need to find the third one. And if they talk about the converse, then you will be given with all sides, and they will ask you to find. Basically, this Pythagoras theorem forms basis for trigonometry. So trigonometry is very important. It is very clear. Trigonometry is very important. Trigonometry is a bit tricky. Trigonometry is a bit tricky and very important. And Pythagoras theorem forms basis for trigonometry, and trigonometry is forms basis for bearings. So you know something about bearings? Yeah, it is like finding angles from the north. There is some north pole, and we need to find the angles in clockwise direction. Yeah. So these are very important topics from IGCSE, basically GC and IGCSE both. And let's see. We will start trigonometry in the next lecture. So I'm gonna share some of the questions with you for the practice. You need to do those questions whenever you feel free. If you feel any difficulty in solving those questions, you can ask me, or you can email me, or you can ask in the in our WhatsApp group. Okay, you are free to ask at any time. Just leave me a text that I'm struggling in this part, or I'm struggling in this statement, or whatsoever. You can just leave a text there, or you can send a screenshot that I'm struggling in this question. So you are free to ask me anytime. Okay. So it was all for today's class. If you have any questions related to this class, or if you want to ask anything about the topic or something, you can ask, please. Okay, thank you. It's a great lesson with you. Take care. Bye. Yeah. Bye bye.